Hello, good afternoon, friends, all student friends, all of you for getting selected for the grand finale. We will be starting the session, training session, very shortly, maybe in a minute or two. Hello, Jobby sir.
Hello, good afternoon. Good afternoon, Joseph sir.
Yeah, hi, good afternoon. Hi, Pradeep. Hi, Yogesh. Hi, everyone.
Sir, we'll wait for a minute or two as many students are in lobby. My team is adding them one by one.
Okay, no problem. Yeah.
Have you started YouTube live also? Please. Yeah,
Yes,
I think we should be.
yes, we have started YouTube live also.
Okay, great.
Seema, just message me if you're done with this participation ad.
Sure, sir. Good afternoon, sir. Good afternoon, sir.
So shall we start? Jobby sir, Yogesh sir, we are good to go now.
Let's
Yeah,
go.
we can start.
Okay, okay. I welcome all my Smart India Hackathon students. First of all, congratulate all of you for getting selected for the grand finale. As I said, today is the very best and interactive session in the area of the cloud. So we have one good eminent personality from Tata Consultancy Services. But before I speak to him, I welcome and I invite Mr. Yogesh Brahmankar, who is an innovation director of Ministry of Education's Innovation Cell AICTE. Yogesh sir, welcome. Over to you. I would request you to please introduce our new trainer, Mr. Jobby Joseph.
Pradeep, good afternoon, everyone, and I welcome you all for this training session by our expert trainer, Mr. Joby Joseph from Tata Consultancy Services. So, sir, a warm welcome to you, and thank you so much for accepting our request for guiding our young innovators from across the country. So, introducing Mr. Joby Joseph, he is a cloud and technology expert for cloud migration, FinOps, AI, ML, Gen AI, and he leads multi-cloud foundation engineering at the reputed Tata Consultancy Services. So you can understand the level of what maybe the work what Mr. Joseph has been handling, and he agreeing for this session is really a matter of privilege for us, and I'm sure the beneficiaries, sir, the participants of Smart India Hackathon who might be like first year to fourth year of engineering, 90% of them, some of them might be non-engineers also. Okay, they joined because of their enthusiasm and dedication towards initiative of Smart India Hackathon. So we always get 5 to 10% non-engineers also. So this is the introduction of both the sides, and without taking further any time, I hand it over to our respected trainer, Mr. Joseph. Over to you, sir, for taking this side. We are having two types of audience, sir. One is on WebEx, one is on YouTube. My team will help for handling Q&A with raising hands. So we request participants, while session is going on, trainer will not be able to see the chat box. So we can avoid a lot of, you might be enthusiastic to ask many questions. I request to make it structured for both of you because we will have almost 20 to 30 minutes time for Q&A. So please have patience. Let us ask questions at the end of the session where Mr. Pradeep and team will help for moderating the Q&A session. Over to you, sir.
Yeah, thank you, Yogesh. Thank you, Pradeep. Good afternoon, everyone. First of all, I really appreciate all of you to take your extra time and effort to participate in this hackathon, and also congratulate you for getting selected for the final list, right? So really appreciate. I think we need this kind of spirit in our engineering colleges and in this country to make our country progress, right? So you are all the future, entrepreneurs who can have the startups and everything, right? That's why we need. So with that, so today's topic is more into cloud computing. So let me share my screen. How my screen is visible, right? Hello, my screen. Okay. Yeah, thank you.
Yes, yes, visible. Yes, yes.
Okay, so let me try to minimize it. Yeah. So today, so we'll be covering this cloud computing, as I mentioned. These sessions, training sessions, which is part of the Smart India Hackathon. And today we'll be more focusing on the three major cloud platforms, which is AWS, Google, and Azure. Okay. So meanwhile, I don't know how many of you are experienced with the cloud technology. So you can also put some kind of comment in your chat box whether you are experienced or not. I know it's very difficult to get that poll, but yeah. So we'll be. I know there are some mix of participants with or without experience. So I will be considering both your scenarios. Okay. Yes, we'll be high level go through this structure, the overview, then different services, and how we're going to deploy these applications, how to optimize the cost, and then Q&A kind of thing. So first of all, I just want to highlight one thing. This is you may be knowing this Gartner, right? Gartner is one of the leading analyst firms across the globe, which they are giving some kind of insight or strategic trends which is coming up in the future. So I think they recently published a strategic technology trends for 2026. And if you see and there are three major themes, the architects in the system, they grouped into the three themes. And if you see the first theme, what is that? It's a build secure, scalable, and adaptive digital foundations with AI native development platforms, AI supercomputing, and conventional computing. So this is one of the major theme they identified is coming for next. Background noise is coming. Sorry, there's a background noise. Can you mute if you're not talking?
Ashish, kind.
Okay, thank you for muting. So I hope I'm audible, right? Okay. So this is a technology insight. What is happening if you take a top 10, technologies, and some of things are we see what is the inference from that. A huge demand for computing infrastructure with even that we have a huge jump into the AI. Okay, and AI is not only for one particular area, right? In every technology or every industry, or even our personal life is going to be impacted with this technology for next 10 years, right? So and there is a huge need for capacity, right? I still remember when I started my career in 2000 with a first job, and at that point, what was the largest capacity we are saying in the desktop or laptop it is around 256 MB RAM and 2 GB hard disk. That is one of the big good capacity desktop at that point. I'm talking about 2000, that time frame, right? But if you see now, all this capacity is nothing, right? So you can get this capacity in your mobile. This is multiple kind of capacities there, right? So that is why huge demand is happening. Especially AI needs a lot of computing required, and that is what, if you see, there are recent announcements in the market, in the media. There are two announcements. One is that Google Cloud, Google is going to invest around 15 billion in India, right? Building up a very large data center, AI data centers in India. Okay. Similarly, we have also TCS also announced we are going to have another 1 gigawatt capacity data centers coming up in next 5 years across multiple cities in India, right? So these are all because of this technology. We need huge computing, right? So even though AI was there earlier, but it was not able to scale because that didn't have that much of computing power or even the data. You have a peta or exabyte scale of data now, right? A lot of data, right? So that to process the data or to process that into the compute was not there earlier. So that is why it is important, even for you all scenario also. So you may be having a lot of ideas and you do want to do a prototype of the ideas. So you need to get some kind of compute or storage or database to do that one, right? Your personal laptop may not be suffice, or your college lab infrastructure may not be suffice. So that is why we have the cloud is coming here, right? So if you see the cloud, okay, so I know most of you are aware of this cloud computing. The biggest advantage of cloud is the resource pooling. How we can aggregate the compute, storage, networking capabilities, all kind of things in a large scale, right? And then serve this to the end user or a consumer like us, like we serve the electricity. And then and we are all using electricity, right? We are seeing the effects, right? When you're home or in office or in the college or everywhere, right? But we don't know where it is generated and how it is coming to our home, right? Similarly here, the computing model is that there's a large resource pool and compute pool is available across the globe, okay, and we don't know where it is getting generated and an exact location, but we are getting whenever we need a compute server or a database or a storage capacity, so we can get it that, right? That is what the cloud computing is needed, right? And also we are able to access over the internet to standard protocols like HTTP or HTTPS or REST APIs. We can call them all these services, right? And also if we need a scalability, right? For example, your application, you are also doing a prototyping and your application needs a scale, okay, from 100 user to 10,000 user or 1 lakh user, just to scale, right? So then how we can scale, meet that scalability. These are all why the cloud is very important. And also there are 3 different layers. We call it as the infra service, where we are getting the operating system up to the operating system we are get from the provider. A platform service means the provider is maintaining everything, and the software means we are getting like your Gmail or those kind of things, right? You are getting a service. Even the WebEx, currently we are the meeting we are using is a WebEx. It is a software as a service model, right? We are consuming that. Similarly, there are other 3 deployment models. There are private, public, hybrid. To what extent, how we are, to which organization is using. If it is open to all the enterprises to consume, or limited to only one particular organization, or it is a mix of both, or it is selected for only certain communities like universities. So based on that, we have the different categories like in public, private, hybrid. I think you may be knowing all these things, right? So in your use case also, if in your hackathon use case, so you need some kind of computing power. So what you need, one is that you need speed. Okay, we cannot wait. We have to get immediate access to the compute or database or storage, whatever you need for your application to up and running. Similarly, you need that some other capabilities, right? For example, you need to process some of the huge data, right? Or you need to use some kind of, I don't know how many of you are working with AI, AI use cases. So you need some kind of AI services or data services. So all these things we can get a more powerful infrastructure we can get from the cloud. And also scalability I talked about, if you want to scale, okay, so that is possible. That is why the cloud is giving there, right? So this all we talked about. I don't go details here because we all know that this is explained. So this only because to what extent we have control, and the cloud provider like Amazon or Microsoft or Google, they are managing this one, right? So if you say it is like your lab system or your laptop, they like on-prem, right? You means in your laptop, in your lab system, you may be controlling the entire thing, all the layers you are managing, your networking, your storage, all these layers you are managing. But when you go to cloud, the cloud provider, the vendor is managing different stack, and they maintain everything for you, and you get a service, right? That is what we talked about: infra service, hardware service, and software service, like that, right? The more and more we go the right side, we'll get a higher agility, because we don't have to wait, build and all systems. We can go and consume those database or those functions, or their the AI services, anything we can consume from this layer without much waiting time. That means your agility or speed of development or deployment is going to be very high, right? But also cost also getting lower. But if you see the lower side, but you need more control in all these layers, then you can go with the completely on-prem model or infrastructure model, right? So we may be more focusing on the infrastructure service model or platform service model for your use case, because most of the things you may be using any of these services there, right? Yeah. You're moving on. I think if you see the leading cloud players, there are many players available in the market now. But if you see the history, who started this cloud, it was AWS. Okay, so Amazon started. It first came as a use case in their own Amazon.com in the portal, how to scale that portal, how to deploy across globally, all these things, right? So though they created all these kind of components, they made it as available for the worldwide users. That is what this AWS, Amazon Web Service, formed. This was in 2006. After that, they launched new services for compute, storage, database, like that, for the last couple of years, right? So they are leading still in terms of the services. They are a bigger player there, and also we have just below we have Microsoft and Google. Okay, so the first project I handled for cloud, it was in 2015, exactly 5 years before. It was we have to set up the foundation for AWS and Microsoft for one of the Singapore-based customer, right? So that was the we did. Okay, so we did the foundation for AWS, Microsoft. Google was not there that much, because Google was more focusing on the other areas like the App Engine or data services, those kind of areas. But now if you see, Google also came to that track. If you take this is the layer. I know someone has raised the hand. Any questions?
No, maybe we can take questions at last of the session.
Okay, fine, yeah. So I think we'll be more focusing on these three layers: AWS, Microsoft, and Google today. But other than that, you can see other players like Oracle, OCI, Oracle Cloud Infrastructure is there. Another leader in the cloud. Alibaba is there, probably in China and other regions, APAC regions. IBM is there, Huawei, Tencent. All these are the different players in the market now. Okay, but today we are more focusing on these three players: Amazon, Google, and Microsoft, which is the top or big three, we can say today. Okay. So now coming to the how it is structured, right? How they are providing this kind of massive scale infrastructure to the entire world, right? So that is what we as a global infrastructure. We see this how they structured is that if you take AWS, so they have the different they call it as a region, the big data center they set up that is across the globe. Okay, so you can see around 38 geographic regions are there currently, and also 128 availability zones. So this is just to understand the concept of region means it is nothing but a huge data center in a particular location. Like you can say here it is Mumbai, right? In Mumbai location, Asia Pacific, and that is the geographic region. But within that region itself, there will be multiple data centers, because there can be, if it is single data center, there can be issue, right? There can be natural disasters like tsunami or hurricane, those kind of things, right? It can impact one particular location. Because of that, each of the region has got multiple data centers. They are connected maybe 5 to 10 miles away, but they are connected together with very high bandwidth fibers with very low latency kind of thing. So even though they are some few miles away, but we don't see that they are distant. they all are very working together with a very low latency kind of connections we are getting, right? So that's why 120 availability zones are there. This many data centers are there, and you can see these all these regions, right? So and they are created for all the regions. And if you go here, you can see find out. See, this is the you can see here, right? So if you go to the North America, you can see how many regions. South America, we have a lot of regions. You can see some in Brazil, Sao Paulo. Then we have Chile. We have something. It's coming up. Okay. So see, this is what they are saying. They are going to set up, or they are setting up the data centers across the globe. That is what even Google also announced. They are going to have another massive data centers coming up in Vizag in India, right? It is going to be around with around 15 gigawatt kind of capacity, right? So 1 gigawatt watt is not a small capacity. Okay, even if you take the entire consumption of India, now it is a data center capacity is only less than 1 gigawatt. And that is what even TCS also saying. So we'll be in another 5 years, we'll be bringing that 1 gigawatt capacity data centers in India, right? So that is that you can say around thousands of or even lakh families or houses we can consume that electricity, right? Okay, so this is the way it is structured. We can see across the globe these regions are set up, and each region, as I mentioned, they have multiple zones available. Even and that is why they are setting up the global infrastructure across, and we can use or we can get the services from across the globe, right? Okay, now if you're going back, yeah. Similarly, if you go back and if you see the other one, next one is the Azure infrastructure. Similarly, Microsoft also set up. You can see this one of the pictures of their data center. I don't know which location, but you can see how big it is, and it is spread across acres of land, right? And also nowadays the data centers, they are coming up with a very focus on sustainability or green, okay, very limited carbon usage, using wind energy, using the cooling power, water based cooling, and near to the water. Some of the data centers they set up, or R&D is happening, setting up inside the sea itself, so that they can reduce the requirement of cooling, right? So that is why they are setting up. Even Azure also, if you go here, you can see there will be a huge similar things are coming up in Azure. That is also have across the globe 100 plus locations. You can see all these locations, right? So you can see the different locations. We see the India. You can see India has got many regions here, right? This one region is there, Central India, and also another one is in South India, like that. One is coming up in the Central is another is coming up, right? So that's what if you see they are setting up the huge data centers across the globe. As I mentioned, there are regions plus the zones, regions, and a lot of data centers connected together. That is why we are avoiding avoid any kind of single point of failure there, right? Now moving on, if you take the other part, if you take Google, right? Similar scenario, Google also. This is a one snapshot of the entire Google spectrum now. They have around 42 regions. You can see all these locations. In India, they have Mumbai and Delhi. Already 2 regions are already set up. And also we have a lot of regions in US, in the Europe regions, even Middle East, or the Australia region, South Africa, South America, all kind of areas, right? You can see the regions. Okay, so we have also got 42 regions plus 127 zones, and with the network edge locations. The edge locations are more towards caching the content. For example, if you are there's a and the World Cup match is going on, right? And you are watching the YouTube or something, or even Netflix, you are watching something, right? So then you need to get the content from the nearest location. If you are, for example, if I am if I want to have a reliance on the US to get all the data content streaming video, it is going to be a high latency, right? Because of that, the edge locations, what this does, it is taking the content and it will be storing or caching the content in the nearby location in India, the nearby location, so that the user can get a better experience, the viewing experience there. That is why these edge locations are coming up there. for more application like YouTube or those kind of applications where we need more streaming or low latency for the end users, right, with the more caching and everything. So this is why it is a setup. There are and this is not going down. When I started, I think in 2015, this number of regions were hardly less than 10 or 20, that range. Okay, but if you see, it's gone to around 40, right? So it means every year they are coming up with setting up the huge data centers or infrastructure across the globe, and they are getting connected. Okay, so that is the way we are getting. So if you want to get that is the big advantage of this any company or even personal scenario, right? If I want to get some kind of new services, I can get, because for some of the examples we are doing some services where AI services is not available in India, so we have to use US region for getting that latest AI services from the Google Cloud, right? That is what we use. Okay, it is not limited. If you're getting access to a Google subscription or AWS account or even Azure subscription, that means it is not limited. You can go and consume the services across the globe. It is not only limited that you can consume only from India region, right? There is a flexibility that you can consume from any locations. Whatever service available in that area, we can use it. Okay, so that is the global cover. That is what we need, and this is going to increase in future. There are a lot of local data centers or clouds are coming up. It's called sovereign cloud. That is again because of the geopolitical issues. Every region want to set up their own data centers in their country or in their region. That's what you can see more push into the Europe countries or even India also. That's why the push is coming for setting up the huge data centers in India. That is what local data centers in India, so that we can limit our data in our country and then we can use it as a primarily, right? So that's some of the that is called a concept called sovereign cloud, which was not there earlier. The definition, you say public, private, hybrid, and everything, but sovereign is another new term coming up. Is there, and also edge cloud. Edge cloud is means you are just extending that capability to the user locations. For example, if there's a manufacturing plant, then you are having some kind of edge devices where you can get a cloud-like services for your IoT or for your AI or any of these areas. That is why we are getting it's called edge cloud. So these are the new things coming up in the cloud. There will be edge cloud, sovereign cloud, all these things there. Okay, now moving on. Okay, so here this is the structure we talked about. If you see Google Cloud, I'm just taking an example of Google. Here we can see this. We have a one region. This is a Europe location. The Europe location, we have multiple regions there, and then we can take one Europe region is Europe West 2. Okay, and then within that we have a different zones we talked about, right? Europe West 2, A, B, C. Nothing but they are big data centers in different sites or locations, which is connected together to form this region Europe West 2. Okay, so 3 different data centers connected together in a very high bandwidth or low latency pipe, like a fiber connections, right? It is there. That is why it is getting covered. Okay, now that is all towards the global infrastructure, how they are setting up and providing the services. Now coming to this the services. Okay, you have the infrastructure, right? You set up the data centers, Google or Microsoft or Amazon. They set up the data centers across the globe. But then how we can use that, right? So how we are going, what kind of things we can consume from there? That is why this we call it as a cloud services or products from the cloud, right? So typical products you may use in your use case. You need a computer, right? So you need a compute power to run your application or a database, those kind of things. Or you need storage. If you have a massive data to store, you need a storage. Or database. It can be a relational database like a Postgres or MySQL, like that, or Oracle. So we need so all these things we can consume from the cloud. That is what this. If you take any cloud services, there is a plethora of services available, right? That is some kind of notifications coming up, so you can. Okay, so now this is one example of this AWS services, right? If you take this section, you can see we talked about the regions and the zones and edge locations, which is the global infrastructure that they are maintaining, the huge data centers they are maintaining across the globe. Now on top of that, you will get different services. For example, you need networking, you need a firewall, you need a the gateways, load balancer, VPN connections, how you're going to connect from your home to the cloud or your lab to the cloud, right? All these things. So networking areas. Then there'll be a lot of compute services, right? You have it's called Amazon called EC2 Elastic Compute. It's nothing but you get a Windows or Linux kind of operating system with your own required capacity. Okay, how many vCPU or memory you can consume there, right? Then we have this the storage is there, the different type of storage where we can keep petabyte of your data, or it can be your some archival data you need to dump. You have taken a huge photo, but you are not using that one. You want only just archive, right? So last 10 years of photo you want to just do archive so that you can refer in future. But you can get a fraction of cost. You can get a archival storage, right? The only purpose is that you want to keep the data. You don't want to lose the data. So after some years you will keep that in archive, right? So like that there are a lot of services. Then your application services, how you create an application for email sending or queuing, all kind of areas. Then your analytics services, right? If you want to have a big data set, big data, how you're going to manage it. Then we have databases, as I mentioned. It can be MySQL, Postgres, or SQL. Those kind of databases, how you can get it. And also there are a lot of security, because very important, right? We say it's a public cloud. It is accessible across the globe over the internet. That is very important to have a security. I still remember when we started this cloud, right? One of the biggest, I think 2015, 2016, that time, when you're going to customer, the number one question they're asking was that, is it my data secure? If anybody else will get access to my data, all kind of things. We have to answer, give the answer. No, it is secure, because the way these hyperscalers are coming up, like AWS or Azure or Google, they are investing billions to make this kind of security possible, right? That is not possible for even a single company or a single user, right? So you have to, I will typically give an example. Okay, so how we are keeping all our precious items like your gold and everything. Now gold is going to be big, highly precious, right? So we are using locker, right? Rather than keeping in our home, what you do, you use locker, because locker provides a lot of capability with a manned security plus better safe, all kind of things, right? That is why we moved to the locker, and we get a fraction of a money cost, we will get that service, rather than keeping in our home with all this kind of setup our own. We want to buy our Godrej locker, or if you have a manned security, it's going to be a huge cost as an individual for me, right? But if I am leveraging a bank locker, this is a fraction of a few thousand rupees, I can get a service. Similar thing is security also is going to be a huge thing there. Similarly, there are a lot of operation management. It's not only for that one, you have to manage that one, right? Once your application is deployed, whether application is working properly, any errors is coming, or how it is scaling, all kind of things. And also there are a lot of other services for your development. As a developer, you need a lot of services, software development kits, all kind of things. So these are all the plethora of services that cloud providers are providing. And if you go here, you can also browse this one. Okay, if you go here and you can find out what kind of services they provide, right? Okay. So now moving on. So let me show you one example so that you can also relate that. So I just go to our AWS console. So this is the AWS console. I have taken to one of the subscription or account, and I can see all the regions here. You can see, right? As I mentioned, even though I am using the account, but I can provision services any of these regions. You can see US, we have four regions. APAC, we have Mumbai, or Mumbai is there, right? And then we have Canada, Europe. So if I want to provision anywhere, I can go and use this region to provision it, right? And also, as I mentioned, services, the compute services we talked about, a number of services, and containers. This is another area, right? A lot of even when you are using your application also, you may be creating a Docker container and deploying it, right? So container deployment is another way of best practices we use in the cloud. So you are making this application microservice based architecture, and also you deploy that application, your APIs, your code, everything into a containers, right? Then we talked about storage. Lot of storage are there, different purposes, object storage, block storage, the different type of storages are there, backup, all these areas. Then we talked about databases, different type of databases having different capabilities, highly scalable databases, which is some having the relational database, no SQL databases. All these things we can get as a by go and consume it. If you want to set up everything your own, it will take maybe weeks or months to set up everything. But if you want to go here, you can consume it directly, right? Similarly, there are other services, networking we talked about, the DevOps tools we talked about, the blockchain. Even you can see the future technology coming up, the quantum technology, right? Because the scale that AI is going nowadays, it's saying that after few years, the current technology may not be sufficient. So everybody is experimenting on the quantum technologies now, right? So the quantum technologies, then you can see all this the management and governance areas. So plenty of services to ensure that you are bringing proper governance and control for your services. The media services, especially for you, the content creation, the video streaming, media live or streaming, those kind of areas. The machine learning, these are a set of services for your machine ML, right? AML applications. See how many type of the different type of services they provide, which has got these different use cases, right? It can be a voice text to message or voice to text, a lot of translations, all kind of services, right? Then analytic services we talked about. If a huge data, how we are going to analyze the data? It's called big data, right? So then we have other services for security and identity we talked about, starting from your identity management, your firewalls, your all kind of different services. Then the billing management, right? How you ensure that you are paying for whatever you are using, right? Then application integrations, then and then business application, even end user computing, right? You need workspaces like that. Then IoT services. So like if you take any of this technology area, the cloud is providing the required services so that you can go and consume the services and your application development is going to be easy. Okay, so in the earlier era, when I started, that was one of the biggest challenge, right? I still remember one of the ERP implementation, one of the customer we did. The huge exercise was to set up the initial development environment and the production environment. A huge time was wasted there. You have to set up the data center, all the connectivity, all the cooling, power, everything has to be set up. That was a big exercise at that point. But now if you take, I don't need to worry anything. I can come here and provision services as and when needed, and scaling and everything is taken care. This is what we serve the cloud services there. Now coming to going back here, similarly if we go to the Azure, Microsoft, Azure also has got a similar set of services you can see here. Okay, so if you go here, you can find out all the different Azure products, all these different use cases. I don't go into details, but you can say starting from AI and machine learning, to your DevOps, IoT, media, networking. All these services are there. Even compute also, there are multiple services, right? You can provide. You get a VM, or you get a container, or you get a even quantum also. Quantum computing also you can get here, right? So this is the way it is helping to set up our research and development, or even the prototyping of the ideas very easy, right? So but because we are paying only for whenever we are using, okay, and after that, after your POC is done, you can just terminate everything. You are not paying for that. So whenever you are using, we have to pay, right? That is the way it is structured. Okay, that is we can reduce that capex, right? You don't need to pay a huge amount from your pocket to start building. So you can just come here and consume it and then use it. Similarly, if you go to the Google, right? Google also having a lot of services. One good thing I want to highlight, Google started with a lot of focus on big data services, data warehouses, and AML platform. This is a strong capability of Google. Gemini, Nano, and everything you maybe tried out, right? So and Vertex is one of the leading platform from Google. And BigQuery was one of the most famous product from the Google ecosystem, from the data warehouse. You create a data lake or huge petabyte or exabyte scale of data you want to analyze and create a machine learning models or anything. So you can use the BigQuery, right? So this is a set of services. If you go here, you can explore all these things. If you go take all this, you can see AML also. There are a lot of services we use for that, right? I talked about that one. Then you need compute. Taking infrastructure, you can get compute services, your virtual machines or high performance, even graphical processing unit. That is what we need for AI training kind of thing, right? Then TPUs, virtual machines, then so all these are the different type of infrastructure you are getting from the Google Cloud, right? And not only that, but you will have all the database, analytic services, application development areas, then security services, all are there. So what we need is that we should be knowing, and we have to use the right services to ensure that whatever we are building is secure, so that we have proper access control, we have proper authorization, we have proper network access control, and we can ensure that nothing is compromised, right? You are hosting your application in a secure way, right? That is the way it is set up. Okay. Yeah. So if you go to Google also, I'll show you the console. So this is the Google console, like AWS I show here. So this is the Google console. So you can see if you go to any of the things, you can find out the different services. You can see these are all the different services. If I go to the compute engine, I can see what kind of engines, the VM instances, machine images, TPU. TPU is one of the the graphical processing unit from NVIDIA, right? The TPU is the one proprietary from Google, right, for the AI training, right? So then disk storage areas are there. Then so you can see a lot of service they're providing in compute, and also the other areas Kubernetes engine, which is we talked about a container platform, and Google was the one by pioneering on the Kubernetes engine, which is a container orchestration platform, and they made first things, and they made it open source, and then that is one of the and all the platforms are providing this Kubernetes engine. Google called us a GKE, Google Kubernetes engine. Azure called us AKS, Azure Kubernetes services, and AWS provides EKS, Elastic Kubernetes service, like that, right? So we're providing, right? So you can get all these services, right? The being as compute or storage. Storage also, you can say there are different options. We can create a storage and create buckets and use that bucket for uploading your here, right? So you can put all your data. It can support, it can scale. The advantage is it can scale petabyte of data. We can put it there and we can do it. Okay. So that is the services part. So if you want to do a provisioning, just go and create a bucket and just give all the details, right? So you say, okay, go here and give a bucket name, for example, my archival bucket, right? I want to my use case is I want to put all my photos or videos, earlier videos. I don't have space in my mobile or my computer, so laptop. I have to put all archival, right? So I can put this one. I can say where want to put your data. You can see multi-region, single region. Multi-region means it is spanning across multiple geographies, like in US or APAC, multiple regions in Asia or multiple regions in Europe or multiple regions in US, like that. We can scan it. Advantage is that even if a single region is failing, the entire Europe West region is failed, right? Then but it can cover. Even in APAC, you are putting a storage here, means Asia multiple regions means even if one region failing, right? One maybe in Delhi region failed, I can get access to the the data from the you can see multiple location. My data is not lost, right? Then we can put all other areas. So only thing, you just create a bucket. Once you create a bucket, then you can start uploading your data, dumping the data here, and then put proper access control, right? Who want to access and then what kind of aging. So whether I want to put only archival or you need to move to some other the different tiers of data to optimize the cost, right? Okay, so that is the services from the Google side. Okay, so this is what we talked about, is how they are providing, right? If you take the different providers, if you take Amazon or Microsoft or Google, they are providing a plenty of ready to use services, being it as storage or compute or anything. Okay, so I will also just show you how to do a quick provisioning of a VM so that we can understand. Okay, let me take another one. Okay, and then one thing, so they all these things are there. They create as a standard container called projects. Google use a container called project. Nothing but all your resources that you are provisioning is clubbed under that particular thing, right? But in AWS it is called AWS account. Okay, in Azure is called Azure subscription. It is nothing but you get a logical container. In that container, you can have all the resources, being it as compute or database or storage, whatever you are provisioning, you can go to there. So if I want to create an instance, right, I put a compute here, so I can go and create an instance, right? So instance is I'll give an instance ID. Okay, now we can see the region, right? I talked about where we want to put. So you can see all this here, no, low CO2. Low CO2 means that this particular region has got a very low carbon emission. Because if you have some kind of green IT, right? So some demand that you have to use a very sustainable solutions or very low carbon consuming things. You can go with this kind of regions. But some regions, but why they calling it as a low CO2? Because that may be using some kind of wind energy or green energy for the data center. It may not be using traditional methods of power generation. It may be using some kind of green power generate, green power in that data center, or it can be using some kind of liquid cooling for cooling. So that means it is reducing or consuming less power in the data center per the workload, right? So if I want to use in India region, I can go and select Asia Pacific, and I can select the Mumbai region or Delhi region. Can go and I can put and so on. I talked about here. So in Delhi region also we have a collection of data centers here. You can see South 2A, 2B, 2C. It's nothing but data centers connected or data center connected together in the Delhi itself, right? But we don't know the exact location because of security reasons they don't share where is exact locations. But it will be showing here, right? You can see the Asia region. This is the Delhi region with so I'm saying I want to deploy this in a south to Delhi A zone. So then I can give all the details here. Okay, what kind of instance you need? You can see all this predefined instance type, right? You can see the power is coming. So the C4 machine is a very high performing CPU, up to 288 CPU and 2 terabyte or 2.2 terabyte of memory. You can get it from one compute server, right? But I don't need that much distance. I need only a small instance. So if you go for a very small, if you call like a T2 D or something, you can go with a very, or even N1. N1 can go with a very low capacity, right? Okay, you can see the number. One virtual CPU is getting, and you get a 3.75 GB of memory, right? And the monthly cost is around $41, right? So like that. So then you see the advanced configuration. Also, we can give you the options of your operating system. So where we can okay. Yeah, so this will support only the lower versions. So you can go and deploy it here. Right? You see, go and deploy. So if I'm going to use this configuration, what is going to get my consumption will be monthly consumption will be $30. $30 will be the consumption for me. Okay, so okay, then we have to go and create. So it will show where I have to put all the things. Network you have to put. Okay, I think there is no network here. So that's why I cannot provision here. Okay, sorry. So but we need a network also to create that one. Okay. Okay. Okay, so once you select the network, you can go and create a instance there and provision it. Okay, it will not work because it was we have to go some other network. Currently, we don't have network here. It is not set up here. That is what it is showing. Okay, what I'm showing just this is very easy. So just but before that, we have to do some kind of initial work. We have to set up the private cloud, and we have to set up the network, and everything has to be set up. Then only we can go and we can provision it. Okay, So that is we call it as foundation work or landing zone work. We have to go and set up the initial foundation to before provisioning any kind of services. We have to do it. Okay. Yeah. So that is the way of services. Similarly, if you want any other services, we can go and with a few selections, few clicks, you can go and the provision the instances here. Okay. Yeah. Now moving on, I think there are other areas we need to discuss about is basically the deployment pipeline. Okay. So you understand that you have developed an application, okay, and you have to use that application or deploy that application using a cloud environment, right? So typically what you do, there is a deployment pipeline, right? So if you take the deployment pipeline, so we call it as it's called continuous integration and continuous delivery, right? The CI/CD. So whenever it is one of the best practices we follow for a typical application development areas. So you may to have some kind of source code repository, right? Because multiple people, if you have a team of 5, so all of your 5 may be developing the code, right? So there should be something we have to have a source control which can merge the code from multiple developers and it can create that thing. So we have a service for in AWS called AWS code commit, which can be used at one. Similarly, once the code commit is done, you need to have the integration part. You have to build the package. So you have a AWS code build for that. Then you also need to do a testing, and code build can be used for your testing also. You build the package and test the package. That is what we call as the CI pipeline, continuous integration pipeline. So your multiple developers are developing, and you are merging the code on a continuous basis, and then you are building the artifacts, and then you are testing that artifact package, and finally what you have to do, you have to deploy that your application to a environment. So that means we are using AWS code deploy. This is some of the services we use for the deploying the application. Deploy can be to a AWS via EC2 VM, or it can be a container, or it can be a serverless function like that. Okay, so that is why it is a typical CI/CD is working a deployment pipeline. There should be different components of the pipeline. So one is controlling the source code, how you are managing source code, then how you are building and testing that your code. Then finally you deploy that package into or your application into infrastructure, right? So this is AWS is called a code family, code commit, code build, and code deploy. This is the 3 major services that AWS provides to create a pipeline where through that you can create your own application code and integrate it and test it and deploy it to the production, right? And there are other development kit and this thing there is supporting the newer way of working, like the microservice architecture and other things, right? Similarly, if you take Azure also, Microsoft also providing a lot of features for your CI/CD pipeline. This is one of the example of this one. We talked about the developer. Developer is creating a code, and this code is in the repository, source code repository, and from there the pull request is happening, and it is a CI, a continuous integration pipeline is getting triggered. All these areas you can see in the PR area. What is doing? It is doing a code analysis, security scanning, and unit test. Those kind of areas is happening here. And similarly, in the continuous integration areas, it is more into more code analysis, build unit test, integration test is one of the key additional things step there in the CI part, right? Then you have the Azure pipe CD part. CD part is nothing but once you the build is done here. So you have the artifacts. It can be a Docker container or it can be another package that you have to push to your the infrastructure which is going to be serving your application. It can be your Azure App Service or Azure VM virtual machine, or it can be another container service or anything, right? It can be your infrastructure, cloud infrastructure here. So that also can be different environments. You may have environment for staging, which is for your testing and user acceptance and everything. But then we have once that testing is done, you may go with your release will go with the production, which is the final one, and going to the end user, right? So all the websites we are using, we are seeing through the internet, right? All these are going through this kind of process, and they are putting in a final production deployment. Once it is from production, it may be accessible over the internet or internally through intranet we can access it, and it is happening. But there is a pipeline. right? So this is what we say. From code, you do the initial code CA part in a continuous integration part, and then your continuous delivery part, and then finally your application is up and running here. And on top of that, if you take the DevOps area, so you have a certain other services like once the code is deployed, then what we need, you need to monitor whether the application have any issues or any kind of if more users are coming, what is the behavior of the application, and also what kind of logs, if any errors are coming, or whenever the load is increasing, any performance issues are coming. All these are we need for your operations, right? That's what, again, there are multiple tools for the operations. This is called the DevOps areas, where we can develop the code, do the build and test the code, and then deploy the code finally in the cloud, and then you use it for the production operations, right? Operating it. This is a full pipeline, you can say. Similarly, if you take Google also providing a certain set of services. So in the previous one, Azure DevOps is a bundle of services. We can use it for that. Similarly, Google also provides a lot of services to do the same thing, a continuous integration, continuous delivery. So one of the source code repositories, one we can say all the source code, and then we have the cloud build is there, which is your CI part. You are building from the source code, you are building the package or artifacts, and then you have artifact registry where you can keep that artifacts. It can be a Docker image or anything. Then you once you approve it, then it is going to go to a deploy. You are triggering the deploy stage. So the deploy can to a staging and production. Okay. So this entire image is created using AI. Okay, that is why you can see some of the spelling mistake here. But this entire image I created using Google AI only, using the Nano, right? The banana image generation tool only, right? So you just give a prompt creating a CI/CD pipeline for the Google. That's why you can see it's still maturing the technologies, but you can see, but it just created a diagram for me, and it is but there are some kind of spelling mistakes that I have to do multiple prompt to refine it. Okay, but this is a pipeline with a CI and CD pipeline we can use. But whenever you are also involved in your application development, you are doing a prototyping and your MVP or minimal viable product you are building. So you will also try to use this kind of pipelines we can use. Okay, so one advantage of cloud is that we don't need to build everything from scratch. Otherwise, you have to find out other tools and manage it, right? You have GitHub or GitLab or Jenkins, and you have a pipe, Argo CD. There are many tools available in the market to do all this CI/CD part, right? But in cloud, we are getting is very easy, so you can use it, and also is highly integrated. We don't need to put additional code or effort to integrate with cloud services, right? I can from here I can put deploy to a Google Cloud Run or a Kubernetes engine or a VM. We can directly deploy it here. It is integrated. Okay, that is the advantage of using this area, the pipeline. Okay, now I don't know, we have no time for the demo and everything, but typically when you are doing in the Google area, very simple interface, we say an application deployment, right? This is Hello World application, right? So a Python application, Hello World application. So what you can use, there is also a dev environment you can get up from the Google. It's called Cloud Shell. Okay, the Cloud Shell is providing an IDE or a developer environment through which you can develop everything, and then finally you can push to a production environment or a staging environment using an App Engine. App Engine is one of the service for the, it's called a PaaS service. Okay, so and where we can host the application. Here we don't worry about what kind of OS I am using, whether it is a Linux machine or another container. All things will be taken care by my App Engine as a PaaS instance will be taken care. Okay, I just want to develop the code and build it, and then you have to push to the deploy the application in the App Engine, and then finally the user can consume it, right? So that's a very simple application. Time permits will go, but I don't think we have time to go through the lab and everything now. But when you say in a real use case, right, when you are going in application, that is a very simple use case I talked about, right? But in the real use case, when you are building a very big application, right? Assume that you are going with a very proper deployment and application. You need a different components. You need a web server, right? Okay. So assume that is a two-tier architecture. with a web app and DB layers. That's called a 3-tier, right? If you have web server, a web server, we can use any of this compute engine or Kubernetes engine or application engine we talked about earlier, right? The app engine, or even Cloud Run, which is a containerized deployment area. That is also we can use host your web server in this area. Then we can have app server also. This the code running, your logic running on the app server can be in any of these computer services. And also your database can be it can be your relational database. You can put a Postgres or a MySQL database. It can put Cloud SQL. And if you need a very large scalable database, you can go with the Spanner. These are our relational database we can go. And also if you need some kind of NoSQL databases, non-relational databases, right? You can go with the Bigtable, Firestore. These are some of the things we can go. For example, if you want to process some of the tweets coming from the Twitter or any kind of areas, right? Your social media platforms. So those may need a Bigtable kind of or NoSQL kind of processing. We need that one. And also we can have the other elements in this here. We have storage we talked about. You need to have a huge data storage, and then data has to be analyzed using a data pipeline, which is using the different data services tools like BigQuery. Especially if your application needs to handle gigabytes of data or petabytes of data, so you can use this data pipeline or data services here. Then the data will come to the storage, and from the storage we can put into the data pipeline, and it will be processed and used by the application, right? And on top of that, you have all other areas. We talked to CI/CD DevOps, right? The artifact registry, container registry, cloud build, then all kind of things. So it can be used for the CI/CD, continuous integration, and your deployment pipeline there. Okay, and also we have the operations. But the other element we are providing is that assume that you set up everything. You have a web server, but the web server has to be available from the internet or intranet, right? So that we can use by the user. That is why this it is providing networking services. There will be load balancing, because there can be hundreds of instances behind, depending on how many users you are serving. If it is 100 user, 1000 user, or a 1 lakh user, so the underlying infrastructure has to be scaled. That is one of the biggest advantage of cloud. You can handle auto scaling, so you use it right. So now you get an IP address and a website URL you get. That DNS is going to be use that name resolution, and the user can use it. A load balancer will do the load balance the traffic, and these systems can do the auto scaling. Depending on the load, it can go up and down, right? It can increase more instances, add more instances, and increase capacity. And whenever the load is not there, especially for a scenario, you are building a retail application, right? Like Amazon.com, you are a retailer, you are building an application for a retail customer. So sometimes some of the festive seasons, your workload will be very high, right? See, the Amazon sale is happening. They're getting a huge hit on during the time. So that is why all these things came. AWS was working on that one, right? They need to handle a huge scalability, right? So they need to scale a lot. So this can be scaled. Then CDN, we talked about the caching, right? If you are especially media kind of applications, the static content can be cached and served to the users, so that their experience will be better. So this is the overall architecture. If you take a multi-tier application with a different architecture components, is what we typically use. But any of this, the message is that if you take any of these areas, whenever you want to put a production scale or enterprise grade application, so you can build it. You can use the different layers of services for handling your application components, right? So that is the application deployment here. Okay, so that's a high level the deployment part. So one thing I want to just highlight is that okay, let me take this cost optimization. Then I will come to that. Your questions, right? I think you are all waiting for the questions. I understand. I'm also talking one side. It is very tough also, right? So some of the best practices you have to consider. One is the big thing is the cost, right? There can be situations the cost is going high, even though cloud provides a better option to control your cost with based on your consumption, like your electricity, right? So we normally talk to or in your family you also see, right? Sometimes the electricity will go up, especially with the summer season or winter season because of the heating or cooling, whatever, right? So that's very important. So whenever the consumption goes up, the bill also go high. So that very be careful on that consumption part. Okay, because the cloud services are priced on pay as you go basis. So whatever you are consuming, maybe a compute per CPU per hour, right, or per minute, we are getting bill, right? The more important thing we have to think about is one is orphan resources. What will happen? We go and as a developer, your immediate need may be you need to get the resource, maybe a computer or database, anything. You go and develop and you provision the instance, but you forget to, and your job is done, POC is done, or your prototyping is done, but you forget to delete that resources. What is going to happen? You are going to get the bill for whenever the database is up and running or computer is up and running. So that may be one of the pitfall, orphan resources, which is even after our actual usage, there can be orphaned and nobody is taking care of that one. The other one is over provisioning. Okay, so this is also important because I saw that the different type of instances, right? There are n number of instances we can assume, even up to 2 terabyte of memory. But do we need that much of capacity? So you see what is your application needs. So and you do the right sizing infrastructure we have to do, just a provision for whatever we need, and enable the auto scaling. That means we can create. There's an option to create auto scaling. We can create a the skill set or manage instance group. Those kind of features which can support the auto scaling. So you start with a small instance and enable auto scaling, and whenever this not using, we can do it. The other one is the data transfer services. It's also important because especially when you are transferring huge data the outside the cloud, right? So normally the cloud, what is happening, whatever data coming into the region or into the cloud, it is not chargeable. Okay, but if your data is going out of the region or out of the network, you will get a charge per GB or per TB like that. So there's a data transfer fee. That's also when you are designing on, when you are considering what kind of data I am putting, whether it is a putting the data into that or we are taking our data out. Those kind of things you have to consider, and accordingly you manage the data transfer charges, right? Some of the strategy one is that the number one rule is shut it down. Okay, so especially if you are provisioning a compute VM, okay, virtual machine, you can stop it if you are not using. For example, if you are a team and your team is only using maybe a morning 8 o'clock to evening 8 o'clock, 12 hour, then why you have to use it for remaining evening 8 p.m. to 8 a.m. That night time you can stop it, right? When you are stopping, you are not going to consume the charges, so you can optimize the cost for that. Okay, and if your use case is over, your POC or your MVP is over, and you don't need that instance, you go and terminate it, so that you will not get even the storage charges also. So that is one of the way we have to see it based on your working hours or working pattern. You can put some kind of automation scripts and you can make the instance up and down so that you can control the cost. Right sizing we already talked about. Start with the smallest one, and the other scenario is serverless. Serverless means it is this is one of the things we normally use, because if you are building an application, assume that your application has got some feature like you are uploading a photo, and the application one feature has to be create a thumbnail or a thumbnail for the photo, right? Assume that is use case. So then it is not a job. The photo may come sometimes. So we don't need to make a server up and running with 24 hours to serve that job, right? So what we can do is that we can create a function, event driven function. The moment some user is uploading a photo to the bucket, then you can trigger a Lambda function or Azure function or Google function. That function can execute your job of creating a thumbnail of the photo there. That is only that fraction of second or a minute that you are paying for the compute. We are not paying for the 24 hours. That is why serverless is going to be a one big savings in terms of cost, provided you are properly designing and managing it. So, and some of the serverless service like Cloud Run, It can go 0 also. If there is no traffic coming up and if it is not invoked, you don't pay anything. But the moment you the users are start uploading the photos in this application, this it will kick start and it will execute the job, and it will be tear down the instance. So you will be paying only for whatever you are using. That is the serverless advantages. And then also then you can got the free tier and student credits. So there are a lot of free tier available in AWS, Azure, and Google. I'll talk to you in a slide. So you can use that. Some of the credits you can available, for example, 750 hours of small VM per month. That is free tier credit. Okay, so use those kind of things to optimize your cost. And also another thing is set billing alerts. Okay, so you can also set up the alert if you're creating a Google project or a Azure subscription or a AWS account. We can also set up this budget alert there, so that if we say, okay, if my consumption goes beyond $10, please send me a reminder or alert, so that I can do. So normally you put an alert when you reach 50%, 70%, 80%, 90%, like that. You put some kind of percentage consumption. You put a budget, and then to reach a certain percentage of the budget, you can put alert and you can put there. This is some of the exam strategies we can put for cost optimization. And then to get into the cloud, I don't know how many of you have got a cloud subscription, but if you don't have, then one of the option we can go with a free tier. We can go and sign up with any of this provider like AWS is providing a $200 credits, and the first $100 you'll get when you are signing up, but remaining $100 you'll get as on when we explore new services, right? Similarly, Azure is providing a $200 credit in 12 months. Google Cloud providing $300 credits in 90 days. But only one caveat here I want to highlight: when you are signing up for subscription, you need a credit card. Okay, because it is not that they will charge the credit card. It is only for ensuring that there is a billing mechanism. So what is happening if your consumption goes beyond this free tier or beyond this credit, then they should have a mechanism to charge it. So they will be validating your billing mechanism. For that, you need to pay. You have to give some kind of credit card, and that will be checking. Maybe they will be deducting $1 to check whether credit card is valid or not. But after that, you will not charge. But unless until you limit your consumption to the free tier kind of services, you can keep your credit card safe. But if you provision some services which is beyond the free tier category, then there can be a bill coming into your card. Okay, that is a caveat or caution we have to take it here. Okay, and then also, as I mentioned, if you are going with this option, free tier option, which is your one of the option to explore the services, obviously use the pricing calculator and see what is the cloud consumption. I show in the compute one of the small instance, it was consuming $30 per month, right? So I can go and check that pricing calculator. If you go to Google pricing calculator, you can see the cost of the calculator. You can say, okay, you can create, okay, I need a compute engine instances. So we can define what kind of instances, how many instances I need. You can also set up hours. That's what I'm saying. So for example, your use case is only using for 8 a.m. to 8 p.m. That is your working window or your experimentation window, right? You don't need to have a 730 hours per month. You can only forgo with the half of this. That means around 365 hours, right? Like that. So depending on that, you can get. So if you go with that, you can see this the price is coming here. But if you say 730 hours, the full month for 24/7 operation, the cost is almost double. You can see around $70 is coming the cost, right? Okay, so like that you can check, and also you can set the OS. Some of the OS like Windows and everything will be always costly because the OS license cost to be bundled. But you go with the free, you can see the free OS, the Debian, CentOS, Core OS. These are all Linux flavors, which is a free OS license. You can use that license here, right? But if you go with the Windows or other things, Red Hat and everything, it may be a paid kind of OS licenses, right? Okay, then you can check what kind of machine type. You see the series. There are a lot of series are there. Okay, with different levels of compute and everything. I need only N1, right? A small machine. It's got a N1 or machine type. I can select it, right? N1 standard. Okay, with the how much? I can select one CPU and 3.75. If I don't need 3.75, I can go also with the 2 GB memory. Okay, say one vCPU and 2 GB memory. This is one of the features Google provides to customize the instance, but other providers, AWS and Azure, we don't have any option to customize this machine. But he can go here and see if I'm using only one vCPU and 2 GB memory, my cost is around 37.72. It's a monthly cost, right? But if you are if it is as I mentioned, if you don't want to for only if your intention is to use only for 300 hours in a month, okay, you want to limit only to 300 hours, so you can go with a so your only $13 will come you as a cost, right? Like that, you can find out this all these three hyperscalers provide the cost estimation template, the pricing calculator. You can see you can go and AWS has got Azure has got pricing calculator. You can go and figure it out from there. Okay, so the other best practices I want to highlight here, when you are signing up with a free tier or any other account, it's very important to and you'll get a root account. Root account has got the maximum privilege. I'll show you the AWS. So if you go here and I can this is what you can say. I can log in. If you have an account, you can log in as either a root user or an IAM user. IAM user is nothing but you create another user. A root user has got a maximum privilege that that user can do anything. Okay, so it can delete or whatever or change the permission of other users. Everything can be done by the root user. So the root user is a very high power administrative account. So normally we don't use that root user many times. Whatever you do, once you initial setup is done, you create an IAM user. That means a user with less privilege you create, and you can log in with so this then you have an option to you have to give the account ID and okay, so you this is the account you get every as I mentioned, AWS has got a account as a single entity, similarly Google project and Azure subscription. So you have to this is the logical boundary to group all your resources, and if you take this one and then go next. So here, okay, sorry. It's already one login is that's why it is not asking for this one. But I know I have already enabled the MFI. If you go log out and sign out, it will show that one. Okay. So I am user and account ID you get to put. See now you can see the you will ask for the user ID and password. So you have to give the I am user. So I have a user ID and also I have a password. I set up. Okay, now if you enable sign in, so another question enable is MFA. MFA is called multi-factor authentication. So you can also set up a if it is an administrator account, you can set up a multi-factor authentication. You can set up something called a Google Authenticator or Microsoft Authenticator kind of. I set up the Google Authenticator. So whenever I try to log into this account, I will get a code in my mobile, right? There's a authenticator app is running, so I can set up I can get a code. This is what I'll use this code, but this code is going to change, right? Every minute or every second, right? So this is what I logged in here, AWS. So there's a multi-factor authentication. That's one of the best practices we talked about. So you enable that, treat this root account with carefully because it has got the highest privilege. Don't use the root account for normal login or activities. You create another IAM account, and also if it is an administrator account, you go with a multi-factor authentication with some authenticator, second authentication. Other than your password, you have another token or another things you can set up for the second factor, right? Authentication. Then the other best practices we have to say, we have to tag all the resources with proper labels and set budgets and billing alerts we talked about. This also ensure that you are controlling your consumption, right? This is one of the main area because some of scenarios we also have struggle because if it is open to multiple people, some people may forget because till the their production rollout or their POC completion, everybody is looking. After that, nobody will be looking into that. So we have to ensure that this is tagging is done, who are created, and what is usage, right? We talked about shutdown instance. We talked about the monitoring and logging is very important. There are plenty of services provides by the provider, right? Google provides a good cloud operations suite. AWS has got AWS CloudTrail. There are CloudWatch. There are many services available for the monitoring and logging. So we can use that for this one. Enable all of things in your account. Then managed services, as I mentioned, it is more into serverless, right? Because the underlying things they are managing. If you are provisioning a Windows or Linux VM on top of the cloud, then the securing the operating system is your responsibility, because there is something called a shared responsibility model in cloud. The provider like AWS, Azure, and Microsoft, they will be taking care of certain areas. Then you have to taking care of certain other areas. The VM means up to the infrastructure they manage, but the OS and above the customer has to manage. That means you are hardening the operating system, putting all security control, antivirus, those kind of things is our responsibility. But if you are going with the managed service model, for example, Google App Engine, right, or a Google Cloud Run, the underlying infrastructure, everything is managed by Google, right? I don't worry about anything, any patching or security patching or antivirus, those kind of things. Google will take care. I just to deploy my application there and I can use it there. Okay, and also there's another thing called the provisioning. So we shown that the provisioning and everything in the console, but there is another option to automate the provisioning using infrastructure code. Okay, so that is also there are different options available in Google Cloud. It is called deployment manager is there, or in Azure ARM, Azure Resource Manager is there. In AWS CloudFormation template is there. Using that, you can define your structure of your cloud resources in upfront, and you can validate and you can do it. Similarly, there is also a third party, not third party, a neutral tool available called Terraform, which is one of the default standard now for the infrastructure code. You can create a Terraform code. Using the Terraform code, you can provision the services that you need, be it as a compute or storage or networking or database. Anything can be provisioned using Terraform. The advantage is that one thing we are putting everything as a code, right? The infrastructure code, like your application code, we are also putting infrastructure code, and that you can validate upfront before deploying. And also, if any issues coming, you can rectify it. And also, it is we have a traceability, right? Who created what and when created, all kind of things is coming there. We know what steps are done, and that can be also linked to your CI/CD pipeline. Like a similar way application deployment pipeline is happening, you can also put your into the infrastructure code pipeline. Okay, yeah. The last one I want to highlight, the zero trust. Very important to ensure that we have a proper network access control. I think you have seen some of the news about the hacking and everything, right? That is because the people deploying, they may not be worried about if your application using public IP and exposed to internet without any proper firewall control or logging and this kind of things. So what will happen? Any hackers can use that one, right? Because hackers are also scanning. They are checking which is the system which is vulnerable or which is not protected. So it's very important to check all the layers, your network control security, your virtual machine security, or database security, all the layers. We need to ensure that we are applying all the best practices that the providers are providing, and use a zero trust model. That means we are not trusting anything. So assume that there will be a hacker and they will be trying to penetrate and get into our application. So that we are very important to have the different layers of security, starting from application, infrastructure, network, all the layers, OS, all the layers. We have to have the proper security there. Okay, so that's a nutshell. I think I have covered a lot, so we can have some questions answers now. Or somebody can walk through. If questions comes, they can also answer there. Yeah, Agastya, I think you are. Okay, so let me go through the questions there. Okay, one question was Dave asked, is there any significant latency trade-off when using cloud services for computation, right? In my view, it is not there because see, most of the scenarios, what is happening whenever we are deploying an application, it will be typically everything in the cloud, right? Your data will be in the cloud, your application will be in the cloud, and all other things will be, database will be in the cloud. So everything will be, together. In that scenario, this latency part, as I mentioned, all these providers are providing very low latency connection among the data centers, and you don't see that it is a connected, even millisecond kind of latency is there, right? But some of the application which needs very high management. For example, you're saying that you have an application which application needs to take the data real time, right, from the ground. For example, it is a manufacturing plant where you are getting the data from the plant machines, or it will be a self-driving car. The car needs to get the data from the local, right? Those kind of scenarios, you might be right. That may be we need a local processing because the frames or everything is coming is very huge, and we cannot transfer everything to cloud. In that scenarios, we may take a local processing there, and then you process it locally, and then you go to the cloud. That is why this edge cloud is edge computing or edge cloud is getting prominence. So wherever you need a very low latency kind of processing required with the data, okay, you are producing huge video streams, and then that has to be processed locally, and then you send the extract to the cloud. Okay, that is why edge cloud is coming picture. Okay, so there many of the providers like Google, Microsoft, they are all extending that cloud capability to edge also now. You have a which is manufacturing plant, even a self-driving car, those kind of things, right? You have the edge cloud capabilities. So you process the things which is near to your data, and then you transfer the end result or extract to the cloud. That's why you are reducing the latency part. Hope I answered the question. Yeah, so you're asking from Kerala. Yes, I'm from Kerala. I'm based out of Kochi here. Recording, I think maybe Pradeep or they can answer. I think it is we'll get that recording, I believe. According to which services would you recommend? See, this is a tricky question because I worked with all the three. Okay, I started, as I mentioned, in AWS and Azure in 2015. I started Google. I think last 5-6 years I'm working with the Google. In my view, all these providers are providing better services. So only what I see, if you take the data processing and AI services, Google has got some better capability in my, because I use that one currently predominantly. Okay, but other than that, it's all the three are good in all the services, because if you are taking basic compute and basic storage, all three are good. As I mentioned, Google provides some flexibility in the customization of the CPU and memory, so we can use it there. Okay. Can we use other cloud providers apart from Google, Amazon, Azure? I'm not sure. I think they have also some kind of free tier mechanism like Oracle Cloud or IBM, but I'm not sure. We have to check the website and find out. So whatever the free tier capability available, no, I think most of the providers provide. Even Alibaba also, I think, provides some kind of free tier, I believe, so that you can use. But today we covered these three because these are the top three according to our study and the Gartner projections and everything. So, but yeah, the other providers also you can get it wherever the free. You just search their websites, and you can get the free tier eligibility there. But others also, if you have want to pay it, you can use for any provider. You can use it. Yeah. How important is DevOps in hackathons? So I don't know this full criteria of the DevOps. DevOps is one best practices we have to use, especially if you are going with a critical application, a sensitive application kind of thing you are developing. So DevOps is very important. How you are going to ensure the code is secure, the different security testing, and also the how we're ensuring that this application is going to work properly after deployment, the monitoring, scaling, all kind of things, right? That's so in that aspect, DevOps is important. But since you are building a prototype and everything, I'm not sure. But that methodology, or if you're adopting the methodology, it can be have some kind of high value, I believe. Okay, the architecture that you're creating, that it can be influenced, I believe. Maybe the SIH coordinators can answer more into that. But it's the best practices. Okay, using CI/CD and DevOps is the best practice, especially if you are going to some code-based solutions you are developing, right? Okay, this session, this is more into an orientation. So if you are planning to do some kind of pilot or POC for the your idea, I don't know which idea, whether it is a code-based idea or it is hardware, we don't know. But this is more the my understanding is that some of the areas where everybody can use horizontal areas which can adopt, because cloud is not limited to one area. See, tomorrow, as I mentioned, if you AI technology or IoT technology or a robotics technology, everything AI, this cloud is going to be the backbone of the compute, right? In that angle, we can use it, and also it is going to help you to do a quick prototyping, right? So if you are building something, and if you are purely based on your mechanical or other areas, it may be not required. But most of the scenarios, if you are building something which is related to all these technologies and a code based kind of solution, it is going to be help. That's why it is giving a generic overview of the cloud. Whether we can use it or not, it is up to you. And also it's important for after your idea is selected and you are moving to a productionization of the idea, right? So you create a prototype and MVP and showcase. That is only a initial idea, right? But it has to go scale. The scaling part you have to deploy, make it as proper with all the security and with all the guardrails. That is why cloud is going to help to deploy your application in the cloud. Recording I already talked about. Okay. Free cloud services to train AI models. I think there are some services like Google AI Studio. We can go and check it for some of the low models. We can check that one. So Azure also, I think there are some kind of services providing there. It's a free experimentation kind of services we can leverage, I believe. You can search for AI Google AI Studio, which is one of the free things we can get it there. But it is limited. But you can also try it out, explore some of the use cases there. And also other frameworks in a scikit-learn, this kind of things are available. You can also use it there, right? Yeah. Yeah. So I told her this one. Even though you are from different domains, this is only a icebreaker for you to. There is a potential usage of your this technology can be in your future use cases and also related to work. Okay, because cloud is going to be one of the horizontal technology which can be used for anywhere, right? Because of the AI and other penetration. So it's one of the area, right? It is not, as I mentioned, this is not limited to only one area. Even in the IoT or a when the different areas, cloud is getting helpful. Okay, which is manufacturing or different industries, right? We can use those cloud services there. So this question, I don't know whether it is to me or not. So So we have some kind of setup we can do, but not all. But I think you have to check the feasibility of that one. Normally we share the generic training to all, but individual mentoring I have to check internally. Yeah. So how can we build our MVP using Google Cloud services? Yeah, first of all, I think as I mentioned, I should have a Google, you need a project. Okay, you have to sign up there. So if you see the link I shared, you can go here and do a sign up here, right? So if you go to this one, this is the free tier, right? I don't know what annotation, I'm not sure. Okay. So this is the one. If you go so this is what you can say. You can go and there are some free tier products are available. So and then you can go and try it. But currently I have already a console. I have already subscription in my ID, so I cannot go here. But if you have a free new, you can go and register your ID, and then we can build from there, right? Okay. So that's why you can go here. So just to go and search for the Google sign up, do a new sign up, and then you can do it from here. Okay. Yeah, I think this I already answered. I think we don't need a concrete DevOps, but I think you can. It is up to the evaluators and this thing jury. I don't know. You can maybe Pradeep or someone can answer this question. Yeah. Yeah, the PPT I will share with our coordinators, Pradeep or Yogesh. So they can, great, yeah. Yeah, please limit these questions only to the technical or related session. All the other processes and everything, you can hold it. It can be asked to the respective team. This is if you have questions about this session and the cloud services, probably you can cover it here. It's easy to filter it, right? I think this is up to you to decide depending on your budget and everything. So if you're going with the paid and also the feature, right? Some of the features may not be available in the free software. So you have to depending on that you have to use it. Yeah. Yeah, I'm sorry. I think this session is more towards a technical session on the cloud, but this whatever the session, the questions related to the SIH and other processes, please discuss with the coordinators, your respective nominated people, assigned people. They can help you on that. Okay. This is all the questions related to the cloud or technology areas. Maybe I will be answering here. See, this question is how do you prevent vendor lock-in for our products in hackathon? Because using third parties in our innovation, it always risky and is a good idea. We do manage the and cloud when hosting the DBAs. See, whatever the code we are developing, that is our IP and your intellectual property that you are developing, right? The only thing we are using this cloud for the deployment perspective, right? Maybe you deploy it on top of a container or deploy on top of a compute engine that you can deploy, right? So you go with some kind of options we can portable. That's why when you are normally we have with the container based deployment, it is portable. You can deploy in AWS, Azure or Google anywhere, right? We are going with a VM based deployment or container based deployment, you can go and deploy. But whatever code that you are developing is your IP, you can protect that one there. Okay, once you have access to the subscription, right? Whatever data that we are saving there, that is secured. That is, we don't have any access to anybody else. Only you will have access. Whatever people you are authorizing, that they have only access to the data and code that you are developing, right? So I think there are a lot of mix of questions, the general questions and everything. So okay, so one question was more into communication to be used when you need to push to the data from forest area directly to cloud. The method we can use push data from forest. See, the forest, I think it will be a very low, intermittent connectivity kind of scenario, right? So I think here the best approach may be allow some kind of local processing, that using edge devices or edge computing or edge scenario, and then you can whenever you have connectivity, you can connect to the cloud and store it there. Okay, so but real time connectivity to the cloud may not be a feasible solution here. We have to use a edge solution here using some kind of I'm not an IoT expert, okay, frankly. So I think that is why we see the architecture. So there should be some mechanism to process the data locally using an IoT edge device or edge computing, and then only the outcome or insight will be shared with the cloud. I can store in the cloud. Okay, that's the way you can do, because here also forest also maybe the connectivity will be one of the big challenge, right? You not have a real-time connectivity there. So local processing will be a better approach. We need a hybrid or edge solution kind of things here applied. That is most scenarios, especially for IoT use cases, right? Ramsha, how yeah, some yeah, my humble request, only you just use this for channel only for the technology query questions. So all other normal general questions maybe use different channels. Okay, so it is a yeah. Because I am also struggling to find out what are the real question. What should be the locations to be corrected since the latest US East server failure? Yeah, agreed. There was a failure there, but I think that was some issues with the US region. That's what whenever for highly critical applications, we apply and adopt of multi-regional setup, the high availability or disaster recovery in multi-regional, right? That is the advantage of the cloud. We can deploy, we can leverage multiple regions with some kind of global. Even Google also supports a global load balancing. That means you can set up a instance in Europe region or India region, and then you can do a load balancing, global load balancing. So that if something happen in the global region, the one region, it can serve from the other regions. Okay, so that's why it has to be an architecture that is again depending on criticality of the application, but it may have a little bit higher cost. But if your application is that kind of service levels, even a single regional outage we can cover through another region. Those kind of architecture is possible. So we have done for different customers. Okay, so that is possible. Yeah, this outage, this kind of outage may be there, but we have to ensure that critical applications has got a multi-regional architecture which can consider this kind of outages. Yeah, so the data leaks or password leaks, right? I think so what is happening if you take the root cause, right? I believe there is one of the I think few years back there was a issue, a big issue on one of the large bank in US, right? And it was an AWS and somebody hacked the data, right? So what we after the root cause analysis and all the investigations, what they found is that some of the employee left the organization. He or she made the attempt to hack it. But what happened? There was a configuration which is not applied. The firewall configuration which is allowing the traffic or filtering the traffic was not applied. So what is happening? The cloud providers are providing a lot of features or security measures to control your access to the data, right? But if the people who are implementing the solution, like you, a developer or an admin, cloud admin, if they are not considering the security, and then if they are configuring, they're putting a loophole there, it can happen. It's not only in the cloud. If same thing happen if it is you are putting your data center and you are putting the same thing, right? Publishing to internet, the same thing can happen. Somebody can exploit some vulnerability and do it. But there are certain best practices and controls given by the hyperscaler. It is our responsibility to ensure that your application design, development, or even the deployment, everything is considering all the best practices, security best practices. So that has to be taken. If somebody is not doing that one, there can be a potential hack can happen. Okay, so if you see the root cause of many of such incidents, the root cause is that the people who configured that system, they have not configured it properly, or they have not considered the security best practices there. How to connect Raspberry Pi with the cloud server and how to deploy the ML and computer vision codes on cloud. Okay, so here I'm not sure about the Raspberry Pi because at Edge, I also mentioned IIT, I don't know how much experience. But for the ML and computer vision, we can use, as I mentioned, Google Vertex AI provides a lot of options to configure the different ML models and this one. And vision also, it is there's an API, pre-trained API available, Vision API in Google, which can be used for that one. Okay, and also Vertex AI, typically we get this kind of Colab or notebooks by through which we can access this kind of services, right? Or we can use that different ML models and train the system. So Vertex AI is one platform in Google Cloud we use. Similarly, there's other Azure has got Azure AI platform. Google has got AWS has got AWS Bedrock. There are different AI platforms available within the hyperscaler. We can use that one for this ML model generation and the vision kind of things, right? So there are use that those kind of solutions, the Vertex AI or Bedrock or even those kind of services or Azure AI platform kind of things can be used there. The Raspberry app, I am not sure. There should be some kind of mechanism like through the edge architecture. We can connect to the cloud using some kind of protocols, right, which can handle the lightweight and low latent, high latency kind of situations, right, to handle. Okay, so and here also we have a certain services. There are a lot of services available in the cloud which can take the data, this kind of systems, mobile devices or edge devices, right? There are certain services which can use it for getting the data, like a Google PubSub is there. Similarly, that you can use for creating a asynchronous connection from the systems. And also there are other services for the managed Kafka, those kind of things. We can use the stream the data there, right? Okay. So, but this Raspberry, I'm not fully sure how to refer it. Okay, this is more an IoT area. Yeah. So, in question, would it be nice to work in the cloud as a student? Is it because as a student our tasks aren't that big? So I didn't understand the question. So see, one thing. No, I don't know what just referring. So I think the student quota and everything we referred only for the free tier kind of thing. But cloud can be used by any people. And what I suggest, no, one thing you have to see the changing in the because of the penetration of AI and everything, right? So the more hands-on, more experimentation from the students itself. Okay, how much initiative they are taking into the this kind of initiative, right? And cloud and everything is going to be a common technology for everyone, right? So, and if you have experience in these areas, it is going to help you to get a better job. And it is during evaluations or interviews, this kind of things will be considered. Your additional experience in this kind of areas is one of the selection criteria, right? So this we already talked about security in the cloud. Okay, I give an example also. See, there are many security services. The way there's a concept of economy of scale, right? I talked about the example of locker. Okay, the way we cannot maintain a locker in our house because of the huge capital investment, right? Or a 24/7 security, manned security. Because we are only one home, it is very difficult. But cloud providers, since they are serving millions of users across the globe, customers across the globe, so they can manage that scale, and the best software solutions or best controls they can implement, right? Being it as physical security or a logical security, because of that is economic scale, and we are that cost is shared by the multiple customers, and we are not getting the huge impact. That's why can say the cloud security is better, but only one precaution there is shared responsibility model. Certain areas customer has a responsibility, certain areas the provider will have responsibility. As a customer, we have to understand what is our responsibility in terms of security best practices, being it OS hardening or application code securing, all kind of things we have to ensure that we are doing from our side, right? Yeah. I saw some in between some questions about the VPC and everything. So MATLAB, I'm not sure. I know this MATLAB. I believe it is referred as this one, right? That data exploratory analysis, right? I think we can use this one. Maybe your data can be in the storage, and you get a big data BigQuery as a data warehouse or data lake. From there, you can use this kind of services, right? I'm not sure. I didn't get the question. MATLAB, I believe it is referring to the EDA, exploratory data analysis kind of thing, right? So what we see typically, there is a lot of integration because we have to store the data and we have to transform the data and inject, have the data integrations or transformation. That area we can have a number of services, and that can be used here. Yeah. So this we didn't cover that VPC. So as I mentioned, the moment we say it is a public cloud means anybody can access. If you have a subscription, you can access, right? But at the same time, we have to ensure that one customer data cannot be accessed by other customer, right? That is called multi-tenant architecture, right? Okay, so here the VPC is one of the option which is putting a boundary or a segregation between one customer data and another customer data, right? So if I'm saying if I'm setting a VPC, that means only and in VPC we gives a better option to give your private IP address. I don't know whether you know there's a concept of public IP and private IP, right? The public IP means the IP is routable internet, which you need for all your internet facing applications or sites, right? But if you are using a private IP, for example, your lab in your college, right? That is maybe an internal IP is using, private IP is using, but for that IP cannot connect to the internet directly. It has to use some kind of proxy or some kind of NAT kind of solutions to connect to the internet. So that means the whatever private IP systems, it is not directly accessible from the internet. So you have that level of routing level, network level security is there, and also VPC provides a lot of other mechanisms to segregate your data from other customers, and also put your firewalls or the different networking setup. Everything can be done within the VPC. So it is basically creating a virtual private cloud within a public cloud, right? So in your subscription, you create a VPC and you control access to who can access my network and who I want to share the data, and who want to do the peering, right? So consider VPC peering. So unless you that network connectivity and architecture you can control, so that is called a virtual private cloud. VPC concept in the public cloud, which is ensuring that a single customer can protect their data, and nobody else can use that data or that cloud for their purposes, right? That is why VPC, virtual private cloud, is used in the public cloud. The traffic handling service that can be used in GCP to handle software traffic or overloads. Okay, so normally the traffic handling, as I mentioned, there are multiple ways. One is the load balancer service we use. Okay, so the load balancer we can use for distributing the traffic to the backend, and also we use some kind of CDN, right? The content delivery network, which can also use it for streaming the data, especially static contents to the nearby locations, right? So those kind of things we can use. Mainly the load balancing kind of services used for distributing the traffic to different systems. So I think we are going to close the sessions now. So I think I answered all the questions. Okay, so okay, thanks you everyone for joining, and I wish you all the best for your next round. And also again, I appreciate your effort you are making. Outside your you have a lot of work, your things to study. Your curriculum itself is so vast. So, but you are taking the steps beyond that, and all these kind of things going to help you when you are going to next phase of your life, right? That is getting a professional life, right? So that is going to help you all these steps. Keep continue learning. Okay, so don't wait. As I mentioned, in future, always how much you are taking additional skills, right? That is what you are going to be eligible, make eligible for your new jobs. So keep that in mind, and continue your, and all the best your effort in the hackathon. Yeah, thank you everyone. I don't know, Pradeep or Yogesh, you are there in the call, so we'll be winding up this now. Yeah.
Yes, sir. We can wind up this session, sir. Thank you, everyone, for joining. Thank you, Jobby, sir.
Yeah, thank you, Seema, right? So who's that?
Yes, yes. This
Yeah,
is
yeah.
Seema,
So
sir.
thank you,
Yes.
Yeah, Seema. Okay, thank you, everyone. Yeah, bye.
Okay, sir.